So, hi, my name is Christian. I'm a PhD student at the UK Biochar Research Centre at the University of Edinburgh in Scotland, and I'm supervised by Andrzej Mašek. And I'm working on work package number 7, which is sequential biochar systems. So my work is based around the question of how can we use biochar efficiently, and I'm not so much focused on the application phase or matching the correct or the right biochar to the right application, but I'm looking at a higher level of that. So in what economic framework or in what kind of system we use biochar and how we can improve that. And to give you a better idea of what I mean is, so that's the most standard system we all know, which is called the pyrolysis biochar soil system, which is
Christian, sorry, because I think the image is frozen. So
okay,
yeah.
Can you let me?
We can try to make in presentation mode.
Yeah, I thought I was in presentation mode.
You are already in the presentation mode.
Okay, can you see it now?
I see the same.
So the
problem is you can move between slides. So you can go, for instance, to a slide manually change the slides. Please, you can try to manually change the slide.
Yeah, that's what I actually did.
Yeah.
But
okay. It's okay.
But you cannot see when I move it, or?
Yeah, you have to move the because it's not the image is frozen. So we always see just the first slide.
Okay. But presentation mode is not working either. I just tried it. Can you see it now?
Yes.
Okay, so I just do it like this.
Perfect. Thank you.
Okay. So yeah. So here, that was the slide. So that's the most standard system. So a pyrolysis biochar soil system where you produce your biochar, you have some production costs, and then you sell it, and hopefully your price is high enough to match your production costs, because otherwise you don't make a profit. And you can summarize that by you produce a biochar and then you sell it. So that's the basic economic framework here. And then we have another prominent concept is the biochar value cascade concept, which is the same idea, but you use biochar for more than one application. So in a cascade, for example, for composting, animal bedding, and animal feed. But on the basis, it's the same principle. So you produce a biochar and then you sell it. So there are some obstacles for these concepts. The first one is this simple product scheme of producing and selling. So this implies that your production price determines your minimum biochar price, because you cannot sell your biochar below your production price in these concepts, because otherwise you don't make a profit, but you make a loss. And the second obstacle is the limited use of the multifunctional nature of biochar. So if you produce a biochar and sell it, you usually target one application. And as we all know, biochar has a variety of different properties. So there should be a possibility to make better use of that. So we developed this idea into a sequential biochar system to remove some of these obstacles. So you can see a simplified scheme here, and that's basically a sequencing of different applications, which will allow to use a stepwise use of its properties. And it's based on the idea to recycle biochar to increase its lifetime. And the goal is that the production costs can be distributed over different use phases. So we only have to get a lower revenue in each of them, with the main goal to lower the initial price of biochar for the first user below the production cost. Because as we know, for example, in soil amendment, biochar is still too expensive for large scale use. So however, there are some issues with this, and they can be described as about the importance of ownership of biochar. So here we have two scenarios. We have the value cascade concept. You, as a producer, you sell your biochar, and then the user uses it several times. So in this scenario, the user has an advantage. However, the producer is still relies on matching his production costs by selling the biochar. In the second scenario, what we can think about is you have a producer, you sell it, and then the user sells it again to the next user. And again here, this price will be the production price. So we cannot, we still are not at a place to reduce the initial price. So what we came up with is that if you start perceiving biochar differently, so not as a traditional product, but as a carrier for environmental services, you can try something like a service-oriented approach. So in our sequential biochar system, you have the production costs, and then you have a user in need of wastewater filtration. So what you do is you sell the service of wastewater filtration by renting out your biochar. And the important thing is that you take your biochar back after it's exhausted. And then after recycling treatment, you sell it to the next user, the next service, for example, here gas filtration, and so on and so on. And this will then end up in something like this. And the important part of a service-oriented approach is that you have a continuous ownership of the biochar. So here, that's all you. And so you have full information about your whole sequence. And that means that's the only case where you can sell your biochar to the first user below its production price and still make a profit, because you know that you will earn money later on and later on. So you can make it cheaper for the first user than it usually would be. And from a research perspective, the interesting thing in such a system is that recycling efficiency becomes a novel characteristic of biochar. So if we look at what time recycling is profitable, we can divide it in transport and recycling treatment, which you need between two applications. And if these combined are cheaper than producing new biochar with the same properties, you are actually making a profit by recycling it. And as we all know, feedstock costs are one of the determining factors in biochar production. So we have a high chance that you find a recycling treatment that is actually cheaper than producing new biochar. And what it also means is that we can talk about recycling of biochar, which means treating a biochar that it can be used for a different application afterwards. So that implies that your application performance is only one optimization parameter now in this concept. So you're changing the perception a little bit. Your production price becomes less important, while your recycling properties are more relevant. Your treatment technologies are not limited to regenerating the original properties like they are right now if you have a regeneration of an adsorbent. So this is really important, because regeneration means you have to restore the original properties while decomposing the contaminant, and that's really not an easy task. And an additional benefit is that recycling will allow to alter your properties of the biochar to the requirements of the next application. So you can do something like a sequence matching by looking at the changed properties. And all of this will just give us new opportunities for biochar development by changing the perception of how we can use biochar. So I can give you one example for biochar recycling, which we tested in our labs. So we designed a biochar that is suitable for a sequence of wastewater filtration and gas filtration with recycling steps in between. So we choose a magnetic activated biochar to increase its absorption capacity for pharmaceuticals from wastewater, as well as the recyclability of the material. That was the plan. So we did normal batch absorption tests. We saw the absorption capacity increases for our activated magnetic biochars in comparison to the non-amended control. And then after this step, we also recycled them using a novel recycling technology or a new method, because usually that's not done. So we subjected our exhausted biochar to a hydrothermal treatment at high temperatures. So we went from 160 degrees up to 320 degrees at autogenic pressure. On the right, you can see what happens with raw pharmaceutical solutions. So we have 10 contaminants. What happens when they are treated at 160 degrees, at 200, and at 280, they are all gone, or at least the parent compound. And then on the left, you can see what I mean with increasing the recyclability of biochar. So the left one is a virgin softwood activated biochar, and the right one is the same feedstock but with iron mixed prior to pyrolysis. And this column at 280 degrees means there are still 30% of the contaminants remaining. And if you have iron there, they are all gone, which means you can lower the temperature of your recycling for the biochar that actually had a high adsorption capacity. And besides increasing the performance of recycling, as I said before, for recycling, you don't have to restore the original properties, because your next application might need different properties. So in my example, I will use that for wastewater filtration, recycle it, and then use it for gas filtration, for biogas cleaning by adsorbing siloxane, which has the property of blocking pores, especially micropores, when it's adsorbed. So in this process distribution, you can see the softwood biochar before the hydrothermal treatment and after hydrothermal treatment at 320 degrees. So you see the mean of triplicates, and the one before is the higher one, and then after the hydrothermal treatment it looks like this. And what we can see is, while we lose some pore volume in the hydrothermal treatment, we also gain some volume in the larger mesopore range, which can be beneficial for biogas cleaning, for example. And interestingly, the other parameters are almost the same. So we have a really high carbon yield. We get over 95% of the carbon we put in the hydrothermal reactor back as a solid. And there are no significant changes in other properties, proximate analysis, ultimate analysis, and so on. So what I want to show here is just that we can develop a lot of recycling technologies that actually are beneficial or give us changing material properties that we can then match to other applications. So as a takeaway message, I want to highlight that biochar is not a simple material, and we might want to try to see it as a carrier for environmental services rather than a product. And this can open up new research areas for us, where we can explore how to recycle or how to reuse biochar in a more complex way. And as I tried to show, is that recycling of biochar can actually be an economic opportunity and can be profitable to do if you have the right framework. Yes, and that's me. So thank you. And I want to say, if you're not registered right now, please register to our webinar series if you want to learn more about biochar. Yes, that's me.
Okay, Christian, thank you for your nice presentation. So we have time just for one question. People are typing. I have a question from Lydia.
So I looked at the functional groups on biochar, and I have to say there's almost no difference. So it's a activated biochar at 800 degrees in CO2, so I didn't expect too much of a change.
And a second one.
Activation step. I don't think an activation step is actually necessary. The biochar still has around 620 degrees square meter per gram and 0.3 cubic centimeter pore volume. So it's still a really good activated biochar actually.
Okay, thanks again, Christian. We have no more time for questions. You can interact using the public chat.